Okay, I just want to make a second video here that finishes talking about domain and range, and maybe we can get a little graphing stuff in there as well. I've got a little bit of time, so I'm gonna place that in here just so that you can for sure see the rest of domain. I want you to just notice what's going on. Okay. So what if I had something like h of x equals 3x over x squared minus 4? Again, do I care about this 3x on the top? No, that's not what determines anything all about domain. It's always take the denominator and say that can't equal 0. Okay, so if it can't equal 0, then okay, I'm going to add 4, add 4. X squared cannot equal 4. Okay, cool. And then I've got that x squared and I want to solve it for x. So I'm going to square root on both sides. But we know that if we take a square root, we put in a plus or minus. So x cannot be the plus or minus the square root of the 4. Okay. But hang on a minute. I can actually do square root of 4. What's that? It's 2. Yes. So I know x cannot equal plus or minus 2. Or you can say x isn't 2. X isn't negative 2. Okay. Again, on the interval notation, if you look at that, here we go. Here's my 0. Here's my 2. Here's my negative 2. There are my 2 holes in the domain. Okay. So it can't be negative 2 and it can't be positive 2. That's what we just said. So as I go to do interval notation, here's my negative infinity. Here's my positive infinity. I know that things that work here are the things below the negative 2, the things between negative 2 and positive 2, and the things above the positive 2. Okay, so for instance, if I put in a 2 here, 2 squared is 4, 4 minus 4, that's a 0. You can check yourself. That would be divided by 0. That's bad. But if I put a 0 in, 0 squared is 0, I just have a negative 4 on the bottom. And there's no rule that says I can't have a negative number on the bottom. I just can't have 0 on the bottom. So that would be okay. So you can do test points in all your different areas like we did when we were reviewing. So watch out for those. If you're not sure, check yourself. Okay, so how am I going to do interval notation for this, this, and this? Left to right, always left to right. This is negative infinity up to negative 2. And remember, can I ever hit negative infinity? Nope, we don't reach that, so we put a parenthesis. In this guy, the negative 2 is an open circle, so that's a parenthesis. Everybody okay? So my answers could be, or my x's could be down here, or they could be what? In between these two. So it could be between negative 2 and positive 2. I'm putting parentheses on both of those. Why? Because they're open circles. Those are the spots I cannot equal for my x's. So those are open circles and they're parentheses. Or where else could my answers be? Up here, right? And so again, still reading left to right, that's from 2 to positive infinity. Okay. And what you'll find is a lot of the times when you're doing this negative infinity to infinity thing, I'll have intervals that go all the way across from negative infinity to infinity, where maybe I have a hole here or a gap there. That's okay. But I get the entire thing in there. All right. So that's what it would look like if it was a quadratic on the bottom and you had to solve for x, or you had an x squared, you had to solve for that. And then square roots, that was the one I wanted to talk to you about. So what if it was j of x? Again, I'm just naming different function names. It doesn't matter. This is the function j. The variable is still x. And I said square root of 2 minus 4x. Okay, what did we say about a square root? I can't take a square root of a negative number. Do you remember that? I can't take a square root of a negative number or a fourth root or something like that. Okay, can't take the square root of a negative number. Okay, so when I go to do that, I say, all right, this stuff in here can't be negative numbers. Well, again, where are my negative numbers? Okay, negative numbers go up to 0, but don't include 0, right? So it's that stuff right there. Those are my negative numbers. This is not my solution. This is where negative numbers live. Okay. So I cannot have this whole thing equal to one of those. So what I would say is the easiest way I think to say this is 2 minus 4x needs to be greater than or equal to 0. 0 is okay. Square root of 0 is 0, right? So that guy's all right, 0. But what I want to make sure is that this whole entire thing is greater than or equal to 0. So again, that's one of those inequalities we looked at last week, right? Okay, so the denominator or the root, whatever's inside of the radical here, 2 minus 4x needs to be greater than or equal to 0. So if it's a 0, we're not negative, we're good. And if it's positive, we're not negative, we're good. Okay, so that's how I set those up. So I set inside the radical greater than or equal to 0. That's how I know I'm going to figure out what things are negative, right? Give me negative answers. And we'll check this just to make sure whenever we get there. All right, so when I do this real quickly, subtract the 2, subtract the 2, negative 4x is greater than or equal to negative 2. And now I need to divide by a negative 4. Divide by negative 4. These are going to cancel out, reduce. I get x. And on this side, a negative and a negative is a positive, 1/2. But remind me real quickly about that inequality rule. I just multiplied or divided by a negative number. What does that do for me? In my head, I hear you saying, you have to flip the inequality. Absolutely. I have to flip that over. So what we're saying is that x can be less than or equal to 1/2. Okay, so find a number that's less than or equal to 1/2. So I'm going to check, because this is the one where it's like, ooh, this is kind of weird. Let's make sure we got it. So 2 minus 4, and I'm going to stick in something. I'm taking the radical, right? That's what g of x is. Make sure we know what we're doing. Coming back up here, right? So 2 minus 4, and I need some number that's less than 1/2. So 1/2 is, here's 1, 1/2's right there. Does everybody agree 0 is less than 1/2? I want to do 1/2 or 0 because that's a nice number for me mathematically speaking. Okay, so if I do that, 4 times 0 is 0, and then 2 minus 0, or I'm sorry, 2 minus 0, yes, is 2. So j of 0, that's my checkpoint, gives me the square root of 2, because that part goes away, right? Is that an okay answer? Yes, that's all right. Okay. If you don't like that, pick another number. Pick -1. -1 is less than 1/2, right? J of 1 equals 2 minus 4 times -1. Okay. And again, -4 times -1, my rule there is a negative times a negative is a positive. So I get 2 plus 4. That's the square root of 6. We're okay, right? That is an all right number. That's okay, that's okay. Those are good check problems. If you wanted to, you could check out what happens if it was equal to 1/2. If I stuck in equal to 1/2, I'd have 4 times 1/2, that's 2, right? Oh, sorry. And I'd have 2 minus 2 is a 0, and I'd be taking the square root of 0. So that is also okay. So if you want one to work with to try it and see, you can do k of x equals the square root of x squared minus 4 and see if you can figure out what you need. So as a reminder, x squared minus 4 needs to be greater than or equal to 0 in order for this to not be a bad spot in my domain. I don't want bad spots, I want the good spots. So solve for x. And that will tell you where you have to be. Okay, and if you have a question about that, I can work it out with you later. All right, that finishes it up. I'm sorry it took 2 videos. Thank you. If you have questions, let me know. All right.